Are you ready for your dream job in data engineering? AWS Data Engineering is booming and companies are desperate for skilled professionals like you. But here's the real question. Are you prepared to land that high-paying job when the opportunity knocks? In this video, we'll walk you through key AWS tools, S3, DynamoDB, Redshift, and show you how to build a solid foundation for a career in demand. Thousands including Coleridge, Pradeep, and Vipin have already used our AWS Data Engineering paid program to land their dream jobs. So will you be next? Also, don't miss our free live masterclass on how to get certified and secure a top cloud data engineer role. Spots are filling up fast, so reserve yours today by registering through the link given in the description below. So let's get started.
Now, let's build the kind of foundation so that all of us are at the same page. You understand the data basics. You know what is that we are going to cover inside the training. And then it is easy for me to kind of map the different services to those particular concepts that we are going to see it over here. So I'm going to go into my first page, the first whiteboard for today. I'm going to start with a concept of a BI lifecycle. But before I go to the BI lifecycle, we have something called as a kind of a keyword called as a business intelligence. The whole goal of the world of data is to get some intelligence. We call it as a business intelligence. Any idea, folks, what is business intelligence? Any idea? What is business intelligence? Come on, folks. Reporting. Is it only reporting? Is BI is only about reporting? Now, most folks think BI is only about reporting.
No, it is an analysis purpose, just not report. It is an
Decision.
addition support system.
Absolutely. Balaji says it is making decisions based on the data. Now look at it. Possibly we call it as a reporting because we know that this is going to be the outcome of the business intelligence lifecycle. But BI lifecycle is much more to it. As Chris already said, Balaji already said, it is all about decision making based on data. It's all about making decisions. So can I simply say it's all about getting insights for business, which helps us in decision making. Isn't it? That's what business intelligence is. How can I gather insights of my business so that I can effectively make some decisions? We would have a decision makers of our organization who would be using this BI.
Three levels, high level, mid level, low level.
Absolutely. Top level, a top management, a mid management. The modern day business says the BI is not just for management. Now you can have a BI even for your low levels and probably for your executives or maybe for your employees. So initially decision making was only for top management and mid management. But the modern day says it's BI is for everyone. Even our low level needs that business intelligence. But the problem statement here is, how do I get those particular business insights? It's very easy to say get insights from your data. I missed that very important term, from data. How can I miss that? The whole concept is about data. It's very easy to say getting insights from data. It's not that easy. It needs a lot of hard work. It needs a lot of transformative work to be done to convert your data to insights. Typically, theoretically, academically, we always talk about this. How do we have our data converted to information? We process the data and it makes it information. Then it becomes knowledge for us. And this knowledge acts as intelligence for us. Now, that's the kind of a transformative work that we are intending to have. Right? Now, to make this data into an intelligence, it needs some kind of a life cycle. It needs a lots of tools, technologies that we need to work upon. So I'm talking about how are we working traditionally? How does my traditional BI life cycle look like? Any kind of tools that you know from your BI space, they would fall into one of these particular phases. Let me cover those phases. You may see I'm going to open up this particular whiteboard at least 10 times during this training because I'm going to map anything that I do, or maybe most of the things that I'm going to do, I'm going to map it to this BI lifecycle. So let's understand what this BI lifecycle is. There are 5 phases of a BI lifecycle. Number 1, number 2, number 3, number 4, and a number 4. There are 5 layers. We have got a data source layer. What is data source layer? Ultimately, everything starts with my data. The organizations today have lots and lots of data. So you are thinking about getting insights from the data, but that data could be in multiple disparate and heterogeneous systems. There is no one single system that your organization would have. I'm sure all of you have worked with different organizations, you're working in different organizations. Think about your organization. Think about where does this data sit? The data could be in the form of databases, which I'm going to traditionally call it as RDBMS. Could be Oracles of the world, could be SQL Server of the world, could be MySQL, could be PostgreSQL, could be DB2, could be Informix, but some database. Your data could be in simple files like CSV, Excels, JSONs, Avro, Parquet, could be anything. My data could be in applications. My data can come from ERP systems of my organization, CRMs. If you know about the NoSQL world, my data could be in the NoSQL databases. So all in all, my organizations have got lots and lots of data. And the sad part is there's no one single source of data. My data might be sitting in different pockets, different kind of sources might exist, which is what we call it as disparate and heterogeneous systems. Now I am here, I cannot build insights on one single source of data. If my customer data and CRMs, my other data is into sales data is into some other applications, my first job is to get my data in a one central repository, one single system. But the question is, can I straightforward get this data into one single system? Maybe not, because the data is different, disparate, source is different, which is where the next layer comes into picture. We call it as a data transformation layer. What is data transformation layer? This is the layer which is required to transform the data, make the data consistent, clean the data, get it ready for a centralized store. So you convert this data into a transformation layer. And finally, I'm going to put this into a data storage and retrieval layer. That's what we do it, folks, here. What is this data storage and retrieval layer? This is the layer where I've got all my organization's data. This is a central data store that I've created. Let me highlight this for you. Now, while I'm showing this to you traditionally, we're soon going to talk about how am I going to replace this with the world of cloud. Hear me out. So I'm going to call this as a central data store. Here we go, folks. So all I've done so far is my organization has got a lot of data, different disparate sources. We have got some data transformed, cleaned, made it consistent, and I'm storing that in a centralized data store. People who come from a data background, or even if you don't come from a data background, this is not that tech question. Any idea what is this called as? Where you have your central data stored. You have the data placed in one central store. What do we call this as? Any idea? What gets created here?
Enterprise data warehouse.
Absolutely. And EDW. Yes, Balaji, even you can have data lakes also. I'm going to talk about data lakes and data warehouse very soon. But typically in the traditional world, what gets created here is a data warehouse in EDW. Right? A data warehouse, or some people might refer it as a data mart. So let me use both the terms. Any idea, folks? What's the difference between a warehouse and a data mart? Is that different? Is it same? How's it? What's the
Mart,
difference between data? Go ahead.
marts are divided into the subject area.
Wonderful, Prama. So data marts kind of are one particular subject area. It might be covering one subject area. For example, I might have a data mart for sales. If I'm doing a sales analysis, I might have only data mart restricted to one subject area, one line of business, LOB. I might have one data mart for marketing. I might have one data mart for financial analysis. So it's one subject area. But can I have a EDW, the word that you guys used, enterprise data warehouse, where I can cover multiple subject areas, all subject areas? In that case, it's called as a data warehouse. But if you're covering one particular line of business, then it is data mart. So to put it simple, logically, they are both the same. Think about a data mart as a subset of a data warehouse, or a reverse, a data warehouse is a superset of a data mart. Now, once you've got the data in a central layer, look at the name that I've given to here, given to this particular layer. It's a layer where you are storing the data, where you got all your organization's data in one single place. But it's also a layer which would now be used from the retrieval perspective. So now I'm going to retrieve the data from this centralized repository for the analysis from your analysis perspective. So the next layer that comes into picture is an analysis layer. Now I'm going to the retrieval side of it. So I am working on an analysis layer. The job of the analysis layer now is to create a data model which can facilitate my data analysis. So in the traditional world, like you create a data warehouse at this stage, we create something called as OLAPs here, or OLAP cube is what we call it as. Or simply speaking, cubes are the old technology. So let me not restrict it to only a word called as a cube. In short, we create data models which are great for analysis perspective, online analytical processing models. And once we have got these data models created, we can then use it for the purpose of reporting and presentation. I have the last layer, which we call it as a reporting or presentation layer. Right? So far we were just thinking about a BI lifecycle is just reporting, but there's a lot that you have inside a BI lifecycle. This is what comprises your lifecycle. Now, if I look at this, there are 5 phases. There is no one single tool which can do everything, which can get your data from sources, transform it, load it, build your data models, and report it. It's a suite of services, products, suite of tools that can facilitate the entire BI lifecycle. For example, what is this first 3 layers called as, or what kind of tools are used in the first 3 layers to facilitate the first 3 layers? Any idea? What kind of tools? What's that category of tools?
ETL.
ETL2.
Absolutely ETL, right? You extract the data from sources, you transform it, and then you are going to load it over inside your data storage. So I'm going to transform it here, and then I'm going to load it here. Here we go. Now, traditionally, there are lots of ETL tools that we were working upon. Can anyone tell me what are the different ETL tools that you have heard of? Any ETL tools that you've heard of? I'm sure there are lots that will come into Informatica and Data Stage, okay? Talent, SSIS, okay? So SQL Server Integration Services, Informatica, Talent, very common ones that you have it, right? Data Stage, not to forget Data Stage. Right? There are others also that you would have heard of, like there is Oracle Data Integrator, ODI. There is Oracle Warehouse Builder, which is used to build the warehouses and all of that. There are modern day tools available today and so on and so forth. SAP BI, absolutely, you can use all of that as an ETL. Similarly, what tools can be used to facilitate this 4th phase? What tools can help me in creating models, data models based on your data warehouse? So from your data warehouse, you can create data models. Have you heard of any tools which can be used to facilitate the 4th layer, building models from your data warehouses? Power Center, yes, I agree. Erwin, to a certain extent. Anything else? So lots of them. Heard of SQL Server Analysis Services, which is used for creating the data models from your warehouses and all of that? Not to forget Cognos and other related tools. Erwin is one of them. Power Center also to a certain extent. They can help you in kind of building those data models. And finally, there are reporting tools and the kind of presentation tools that will facilitate the last layer. Any tools that you are aware of? These are all on-prem as I'm talking of. Any reporting tools, folks? Tableau is one of them. Okay. What else? There are lots of them today. Power BI is one of them. Cognos has got a reporting tool. I love that. BO reporting, Boxy, and then the name changed. What else? So if you are in this space for a very long time, there was first generation tools. I'm going to talk about that first generation tools and why I'm calling it as first generation and second generation tools. There are tools like, if you have heard of Crystal Reports or SSRS or BO Reports or Jasper Reports. These were the tools that I was using in the reporting space. I'm sure you would have heard of some of these particular tools here. I'm sure you would have heard of it, for sure. But gone are the days where we use these tools. These tools have actually disappeared. How many kind of new workloads that you see you are using Crystal Reports or SQL Server reporting services, unless you're working on something legacy? So these tools have been now replaced by DV tools, a data visualization tools. I'm going to call this as a Gen 2 tools, generation 2. where all these tools like Power BI, Tableau, ClickView, ClickSense, Google Looker, Spotfire, right? SAP, SAS BI or SAS VA is what we call it as visual analytics. There are lots of tools that you have in this particular space. But nevertheless, I would put them into the last phase, that is reporting or a presentation. Now, this is what is a traditional life cycle of a BI. The reason for telling you, if you are doing something in the data space, you are probably doing one of these particular pieces. I'm going to go to the world of big data and talk about the life cycle there as well. But when you work with the world of BI, you are probably doing one of these particular things. You're possibly creating your data pipelines using ETL. You're possibly creating data models. You're possibly creating some reports and so on and so forth. So this is what we were doing traditionally. And is this new for us? I don't think so. We have been working with the BI lifecycle for decades now. All these tools, Informatica exists for 3 decades now. SSIS exists for 2 decades now. 2005 was the year when Microsoft launched the first version of SSIS. Before that, SSIS had DTS, Data Transformation Services. So quite old tools. Crystal reports exist for 2 to 3 decades. And the entire BI life cycle and working with that BI is there for decades. But folks, we know that the world is changing. And that's where you are here. All our workloads are moving to the cloud. I'm sure the previous sessions, you were given a knowledge on what is cloud, why do we need cloud, what's the benefits of cloud, working with AWS. Those prerequisites are being set. So when these workloads are moving to the cloud, why would these tools not move to the cloud? Can I run these similar workloads on the cloud? Can I create data pipelines on the cloud? Can I build reports on the cloud? Can I build models on the cloud? Can I build warehouses on the cloud? Now we all know what are the benefits of the cloud. But just to kind of help you so that we don't reiterate this every time, and I know that you are aware of it, can I give you 2 to 3 minutes? Not more than that. I wish I could have given you more. Get me the 6 benefits of the cloud. I'm sure the first few sessions you would have covered that. Get me the 6 benefits of the cloud before I now take this life cycle to the cloud. Get me why should I move to the cloud? Why should my workloads run on the cloud? Come on. Pay as you go, okay? Low cost maintenance, okay? Wonderful Brahma, wonderful Balaji. Thank you. Cost savings, okay? What else? Secure data, okay? Okay, what else? Scalability, wonderful. Accessibility, love that. Is there anything else? So folks, I want you to storage, wonderful. Disaster recovery, okay? I'm going to put the same thing, whatever you guys said. I'm going to put this into a cloud language. So somebody said, pay as you go model. How much you use, you pay for that. Pay as you go model. It's also called as OPEX based model. So we are using OPEX over CAPEX. CAPEX is capital expenditure, where we do a lots of investments on the business and all of that. I'm going to move to the OPEX model. I'm sure you have kind of seen that in the previous sessions. I'm going to call this as lower cost of ownership, or I would say reduced cost of ownership. Which means I am not going to own that things like availability and reliability and fault tolerance and all of that. If I'm having anything on premises, my servers are on prem, my data workloads are running on prem, it is my responsibility, it is my accountability that we kind of take care of those particular kind of resources. It's my responsibility. But when we deploy something on the cloud, the one of the reasons I may be deploying is, or I may be running these workloads on the cloud is, I don't want to own those kind of things. A reduced cost of ownership. Let the cloud service provider take many of my responsibilities and accountability things, and I will focus on my business, which also means that cloud means business focus. I'll focus on my business and I'll try to be agile. If I am a ETL engineer, I'm here to build data pipelines and not think about, running my servers, maintaining my servers, managing my servers, ensuring that my servers are always up and running, they are reliable, they are fault tolerance, they are available in, they can kind of, be, they can work in the DR scenarios, that is disaster recovery and all of that. I don't want to own all of that. I'm a data engineer, I'll focus on the business and be agile over here. Stop guessing capacity. In the world of on-prem, we often kind of think about guessing capacity. How many servers I need? What if there is some promotion that is going on in my organization? There's a big billion-day sale. Would I need more servers? Would I need less servers? I'm just going to guess capacity. But cloud gives you a scalability, which we call it as a elasticity. And how is that possible? We always think about auto scaling. Can I dynamically increase, decrease my resources at runtime based on some condition? Can I do that? All of that is basically scalability and auto scale. Last but not the least, two actually, not last, second last. Go global in minutes. Cloud gives you a chance to kind of go global in minutes. You're running something in one region, one particular kind of your geography. And now you want to replicate this to some other geography. You want to run that workloads in some other kind of your regions. How difficult it is to kind of replicate these workloads, move these workloads to different regions, which we call it as go global in minutes. And last but not the least, global economies of scale. I didn't create a whiteboard of this. I know that you would already be aware of it, but just keep these particular pointers with you. We are going to talk about it at every particular service, multiple services when we go inside it. So what is global economies of scale? Does anyone know what is global economies of scale? These are all cloud terms, not my terms. You look into AWS, you look into Azure or a GCP. These are all the generic cloud terms that I'm giving it to you. So what is global economies of scale? Can anyone tell me? What is global economies of scale? Come on. I got that big one. Refer to the cost advantages that company experience increasing their production at a global scale. I love that answer. So even if it is Googled or from wherever it came, Chris, thank you. Thank you for that. That always helps. Now, to put it short, folks, we are today living in the world of global infrastructure.
Cheap access across the globe.
Absolutely, the cheap access across the globe. Think about the kind of investments that these cloud service providers have done. Just imagine the infrastructure kind of deployments that AWS would have done in multiple regions, multiple geographies. Azure has got has got a presence in most of the countries, in most regions, and all of that. Same as AWS. In every region, then they have got data centers. For example, North Virginia region of AWS. Anybody knows what AWS North Virginia region, how many data centers or how many availability zones it has? Sorry, just trying to test your AWS knowledge. Anyone, folks? How many availability zones in the North Virginia region of AWS? You can Google it. I don't mind if you're Googling it, if you don't know. 6. Wonderful. US East 1A to US East 1F. Now, 6 data centers in one region. Imagine the amount. I'm just talking of one region. There are multiple regions that AWS has. Now, imagine the amount of infrastructure that they have deployed, the amount of investments they have done. And when they have done such a volume deployments, volume infrastructure is what they have kind of provisioned here. Obviously, they would have got discounts. And those discounts are passed to the customers, which we call it as global economies of scale. I also call this global economies of scale as pay less as you use more. We know pay as you go, but do you know pay less as you use more? The more you use, the better discounts that you get from your customers. For example, you would have seen EC2 instances the last week. You can use on-demand EC2 instance, which you will be charged on a per minute, per hour basis. Right? Absolutely, Brahma. 76 data centers, but 6 availability zones. Absolutely. Now, imagine that we are saying that you are going to use on-demand EC2 instance. You'll be paying something for per minute, per hour charges. But if you say that, hey, AWS, I'm going to need a EC2 instance, which is your virtual server, I'm going to use it for a year. AWS will say, oh, don't worry, I'll give you 50% discount on that because you're going to continuously use it for 1 year. Then you say, AWS, I will then give you a commitment of 3 years. AWS says, don't you worry, then I'll give you 70% discount. Now that's what pay less as you use more means over here. The more you use, the better discounts you are going to get on your costing over here. So I want all of you to take that key points that I've put in and always think of a service from those particular perspectives. We are going to go into the world of cloud. So now that I've given you a brief about cloud computing, while I know most of that was covered in the last session, now let's think about that BI lifecycle from a cloud perspective. Can I run these ETL workloads on the cloud? Do we have any tools? Now in the world of cloud, we don't call it as tools. SSIS is an ETL tool. Informatica is an ETL tool. But now the moment I go into cloud, we don't call them as tools. We call them as services, a data integration services, an ETL service. So what could be the replacement of these particular tools, ETLs tools as services on the cloud? In the world of AWS, let me put this in a different color. In the world of AWS, we have got a service called as AWS Glue, a data integration service, an ETL service on the cloud. On the cloud. We are going to see that it's a multi-purpose service where we can kind of create data catalogs. We can crawl the data to get the data schemas. We can create ETL jobs visually as well as with the code. And there are lots of things that we are going to see within AWS Glue. You might ask me, is there any other service? On the Azure side, we have got something called as Azure Data Factory. While not in our scope, just to give you a parallel technology. What is the parallel technology of AWS Glue? Azure Data Factory. Informatica. We know that everything is moving to the cloud. So can we have, a substitute of Informatica on the cloud? Informatica has got something called as IICS, which we call it as Informatica Intelligent Cloud Services. And there are others also in this space. I'm just kind of getting you introduced. My dear folks, we were building data warehouses. In the traditional world, on-prem, any idea what was I using in the traditional world? Let me put this as orange. To build data warehouses, something that I didn't cover it. What was the technology or data store used to build these data warehouses? Any idea? Where were you creating these data warehouses? RDBMS, absolutely. So things like Oracle. If you have heard of SQL Server Parallel, a SQL Server Parallel was used for your data warehouses. There was a focused tool called as Teradata. It still exists. I'm sure some of you would have heard of it. Brahma is bang on Teradata for building those data warehouses. But as I said, we are moving to the cloud. So we need even the data warehouses also on the cloud. We are talking about cloud data warehouses. Any idea, folks? What are the cloud data warehouses that you can think of? Any cloud data warehouses? There are lots in this space. Have you heard of any cloud data warehouses? You can Google it. I don't mind. This is a learning phase. You can Google it. So not to forget, folks, let me give you a start. On the AWS side, we have got Redshift. AWS Redshift. Absolutely, Balaji. Are we going to cover a data warehouse technology like Redshift? Absolutely. So you can run your ETL workloads and kind of have your data stored into your Redshift, AWS Redshift. But is that the only one? Let's see if there's something on the Azure side. On the Azure side, you've got Azure Synapse Analytics. If you have heard of it, previously called as SQL Data Warehouse or Azure Data Warehouse. On the Google side, you've got a BigQuery. I'm sure you would have heard of Google BigQuery. I'm damn sure. Damn sure. So three clouds, AWS Redshift, Redshift on the AWS side, Azure Synapse Analytics, and BigQuery from Google.
Snowflake comes under which one?
Absolutely. The Snowflake. I'm just coming to that. Folks, so not just this, there are specific data platforms introduced to build data warehouses and facilitate all of that. Not to forget Snowflake and its biggest competitor, Databricks. How can we forget that? Even Databricks can bring you those kind of things. See that, folks. So Redshift is one of them, but there are lots in this particular space, and Azure Synapse and BigQuery and Snowflakes and Databricks, and there are other small players also. I'm just talking of the big players. Let's talk about an analysis layer. Do we have anything in this particular analysis layer? Come on. Any cloud service which can help me creating the data models on the cloud. Aware of any service or a tool? We don't typically call this as tools. We call them as services when it is on the cloud. Okay, let me give you one of them. A replacement of SSAs itself. Azure Analysis Services. Just like you have SQL Server Analysis Services, which is on-prem, the same thing that you do on the cloud, deploy it on the cloud, it is called as an Azure Analysis Services. And there are others in this space that can be used here. But generally, now this data model creation can be done with the reporting also. So these two are merged together into one single thing. You don't need a separate tool for creating data models. Now these smaller, at least the smaller versions of these models can be created using these tools also, which is where you don't see many in this particular space now. Lastly, folks, we are talking about the reporting tools like Power BI and a Tableau and a Click and all of these tools. Any reporting tool or a data visualization tool on the cloud. We're talking about the cloud now. Come on, folks. You can Google again any data visualization tool on the cloud. The world is moving to the cloud. The workloads are moving to the cloud. So what could be this reporting tool on the cloud? Come on. Anyone? Tableau, Athena, okay. Athena is not a reporting tool. Athena is a data querying service, Chris. So it may not be, it may facilitate the reporting because you might have a reporting using getting a connector as Athena, but Athena cannot be used for creating visualizations and all of that. It's just a querying service. Power BI, Tableau, okay, to a certain extent, yes. But let's first talk about AWS. AWS has got AWS QuickSight, a pure play reporting on the cloud. Chris, you are absolutely right. QuickSight. It's a reporting tool on the cloud. No installation, no servers required. You can do everything on the cloud. Followed by Google Looker. If anybody has heard of Google Looker, a super tool, a super simple tool to build your data visualizations. No installation, just have a Google account, and then you can kind of go ahead and start working on your reports and visualizations. Folks, why just these two? Everything is moving to the cloud. So we are actually challenging every other tool. So Tableau has got a Tableau cloud. If anybody has worked with Tableau. Now, Tableau Cloud has got lots of things, but one of the things Tableau Cloud has that you can do some authoring even on the cloud. You may not be able to do 100% of report authoring on the cloud, but at least 90 to 95% of your thing can be done on the Tableau Cloud with a not an author license, but a simple kind of an explorer license of Tableau. You can build your reports, provided you have a data model also deployed. Same way, Power BI service, which is also called as a Power BI server. It allows you to kind of build your reports on the cloud. You may not be getting 100% of the features, but at least 80-90% can be done on the cloud. So while you have a Power BI desktop, which is on-prem, which is your standalone tool on your machine, you have Tableau desktop, which is a standalone tool on your machine where you create your reports. You could also use Tableau Cloud or a Power BI service. Whereas the other two, AWS QuickSight and Google Looker, they are born on the cloud. They don't have any on-prem presence. They are born on the cloud. They can only allow you to create reports on the cloud. So folks, that's the BI lifecycle and the mapping as to how we are moving from the world of on-prem to the cloud and also specifying certain AWS services that we are going to cover. I'm going to pause here and ask you for any questions. Any questions, folks? My drive is still not connected. So what I'm going to do is I'm going to create a temp folder on my local. Typically, I keep everything on the cloud. So let me just create a temp folder, and in the break, let me connect to my cloud. I'm going to say K21 batch number 3. And you would see that I'm going to put this in the whiteboard. So let me save this whiteboard. First whiteboard. I'm simply going to call this as one PI lifecycle. And cloud. Come on, folks. Any question as of now? I'll take a pause.
Where will be the data lake will be going in this?
Okay, wonderful. So, folks, data lake would come in this particular stage. So these days, we kind of, instead of data warehouses, we might be using data lakes here. Now, when to use data lakes? How are data lakes different from data warehouses? Just hold on for another, let's say 30 minutes or so, where I'm going to cover the data lakes concept so that you are crystal clear when to use data lakes, when to use data warehouses, and what's the difference between them. But a quick answer, it could be a replacement of your data warehouse, or it could be used alongside with your data warehouse. Both is possible. Both are possible.
The lake
Got
house
it.
is different from the data lake.
Sorry, what is that?
Lake house is different from data lake.
It's a combination of two. So beautiful question, Brahma. A lake house is a combination of two. It's a best of two worlds. So the whiteboard that I'm going to cover all three: the data warehouse, data lake, and the lake house. Think of a lake house as a best of two worlds. Look at the word data lake plus warehouse is what is called as a lake house. Any other question, folks? Okay, I'm moving on. I'll give you a break in another 15 minutes. Let's cover one more, and then I'm going to kind of take a break. But before that, let's cover one more simple thing. My dear folks, this is what was a traditional BI lifecycle. And people who have been working in the data, I am sure you are working on this. This could be a kind of a daily things that you might be doing, a daily operational jobs that you might be doing. It will fall into one of these particular phases. But what's happened of late? Let's look at what has changed in the last decade, or I would say a last 15 years or so. A decade or a 2 decades is what I'm going to say. My dear folks, we got ourselves introduced post 2010 era, somewhere around 2013-14. Like we have a kind of a big buzzword today, which is generative AI. That was a word of the year in 2023, starting 2024. That was a word of the year, generative AI every year. 23 and 24, both years. I would say post 2010 era was the year when we started talking about big data. Now, I would want to understand from you, what is big data? What's your understanding of big data? Now, I'm going changing gears. We know BI lifecycle that exists for 3-4 decades. I told you all these tools we have been using for quite some time now. But then post 2010 era, we got introduced to big data. There was a big hype on that. Somewhere around 2014-15 times, big hype on that big data. And like today, we talk about generative AI. So can anyone help me? What exactly is big data?
It can be
Okay.
stored as a structured, unstructured, semi-structured.
Okay. What else? Thank you, Brahma. So structured, unstructured, all the kinds of data.
Yeah. Simple hardware to split into the blocks.
Sorry, what is that?
Storage, multi-storage of the security purpose. It will store that into duplicating data into storage.
Okay, wonderful. Okay. What
Scalability,
else? Scalability. Okay.
speed,
Okay.
security.
That's
Triple S.
security. Mhm. Okay. Thank you, Brahma. That really helps. Anybody wants to add to it? What is the big data according to you?
We can process and generate and process data much faster.
Okay, wonderful. What else? Anything else? So, folks, put it this way. I'm going to make it very simple for you to understand this. My dear folks, the data patterns and the volume of data, I'll define this, are drastically changing. Every day, every minute, we see that this is changing. If I show you the evolution of data, not to go in detail, but to show you how your data has evolved, how the data technologies have evolved. There was a time 7 decades back, 6 decades back, when we were just beginning on the world of data, we were having the data in the form of punch cards. I'm sure none of us have seen that punch cards, right? Where you used to punch the data and this was only a KBs of data that we were talking about. I'm sure none of us have seen that. We only read about that. If you come from a data background, you would have kind of heard of punch cards, which were used for data punching and storage and processing and all of that. Soon we move to files to store the data. If anybody has worked there also, we were just talking about KBs of data or even MBs of data was a good data at that point of time. If anybody has worked with COBOL, right, mainframe systems, we were using files at one point of time. I have seen this long back in my engineering days when I had a COBOL as a subject. We were using the files for storage and files for processing and all of that. Fox Pro, absolutely. Come on. But that is like a long time back. I'm not going to kind of talk about it. Soon we move to a very stable data storage and processing mechanism, that is databases. Something that ruled the market for quite some time. We have still not gone away from databases, RDBMSs. We are still going to use it and it's going to be used for certain kind of scenarios. We cannot move away from this. But look at the difference when we are storing the data inside databases. Look at this. Databases are good for transactional operations, anything that you want to store which is transactional in nature. And we were only storing the data which was the transactional data. For example, I'll put it this way. Look at this, how the data patterns have changed. If I go back a few decades back, the only data that I was worried about is I perform a transaction, it should be recorded. Now, transaction, that doesn't mean only a banking transaction. I withdraw, I deposit. No, I go to a retail store, I buy something, I return something. Even that is a transaction. Every business has a kind of a transaction that we make. And we were only kind of thinking of recording that transactional data, which is where even GBs of data was a big data for us, or rather a good data to process for us. But what has happened in the last 2 decades or so, or 1 to 2 decades? We are not just thinking about transactional data. Look at that. To give an example, today when I go to Amazon, my mobile app, Amazon, or any kind of equivalent app, I may not buy anything. I may just be browsing for certain items and products. I may be just kind of wish listing something. Do you know? Even though when you're not buying something, you're not making any transaction, but you're generating a lot of data. Imagine how many people that go and visit some kind of an app, they buy. The analysis say only 5 to 10% of the people buy. The others are wish listing, looking into items, checking the prices, doing certain things and all of that, doing comparisons and all of that. That's not my analysis. You can go and look for this particular analysis, which means only 10% of the people are generating that transactional data. They're buying something, they're returning something. They are kind of, generating that transactional data. But there are 90% of the people who are still generating a lot of data, which we call it as an interaction data or a clickstream data. There are different names and subcategories to it. But in all, it's in data that we are generating for by interacting with that application, that mobile app. Clickstream data. And now imagine if I'm talking of Amazon.com, how much of the data they would be generating on the daily basis. First culprit. There is a law, and now while I took an example of Amazon, don't just be restricted to Amazon. Think about the websites that we kind of visit every day. Think about the mobile apps that we visit every day. You may not realize you're generating an ample amount of data, which we call it as an interaction data. Thanks to social media, you're not doing any transactions on social media. But imagine how much of data that we are interacting kind of generating every day, thanks to the posts that we put and images that we put and videos that we put and all. Social media, again, another culprit of that big data. I'm sure some of you would know that when we travel, when you're on flights, there is a black box in the flights. Do you know that one single trip of a flight and that black box data has got terabytes of data that it's stored? I'm saying one single trip. I'm not even saying round trip. Say you travel from a source A to destination. A black box data records every particular thing that happens in the flight conversations, the crew conversations, the pilot conversations, and lots of other information that goes inside that black box data. Do you know that one single trip can take terabytes to maybe more than that, maybe longer trips can take? Imagine the amount of transactions that are happening on the stock market today, right? Imagine these days when people invest heavily into it, the amount of transactions that are happening, these are actually transactional data, but imagine the amount of data that is kind of getting generated. So in short, we now are not thinking about this data which is just restricted to this. We are possibly talking about terabytes, exabytes, right? We're talking about terabytes, exabytes, brunobytes, yottabytes, and there are many more terminologies that I can think about of data. So the first thing that we have here is the volume of data. The first V of big data that we talk about. The 3 V's of big data. There are 6 V's, but let's first master the first 3 V's, basic V's. The 3 V's of big data. First is the volume. We are not talking about gigabytes. Possibly we are talking about terabytes, exabytes, petabytes. How can I forget that? Petabytes of data. Brunobytes of data, yottabytes of data, and so on and so forth. Facebook generates petabytes of data every day. I don't know, this was maybe a good 2-3 years back when I had read this. Could be that petabytes of data now every 1 hour. Absolutely, Brahma. I'm talking of that first V of big data. The second is the variety of data. No longer we are talking about a transactional data. Why did I refer to the transactional data? A transactional data is often structured, what you store inside your databases. You make a transaction, you transfer something from an account A to account B, what amount you transfer, who's the sender, who's the receiver, what is the amount transferred, what is the mode of kind of transaction, and all of that. This is more structured, a tabular format. But today, you're talking about social media, posting images, videos, and anything else. Maybe you are thinking of not just your structured data, you're processing XML files, JSON files, semi-structured data. So variety of data. You might have a structured data. Mostly tabular is what we call it as structured. You might have a semi-structured data. Talk about that as XML, JSON, so on and so forth. You might have a completely unstructured data, which could be some unknown data formats. It could be images, it could be audio, it could be video, whatever that you can think of. And the third is the velocity of your data. It's not just that I'm having a more volume of data. It's not just that I have a variety of data. It is also what is the speed at which we are generating the data. What is the speed of generation of data? How fast we are generating the data? How slow we are generating the data? Like I said, a Facebook generates petabytes of data every day. Today, when we deal with that IoT devices, sensors, CCTV cameras, they are all streaming data constantly. Look at the amount of data that is getting generated, and not just the amount, how fast we are generating that data. Think about that IoT sensors constantly throwing data to your storages and processing layers and all of that. That is the velocity that we are talking about. Now, when I see that I'm having a good volume of data, which cannot be processed by a single system, a single database, I have different variety of data that I need to deal with. And the speed at which the data is getting generated is huge, not that single system can tackle. I am possibly talking about some big data technologies to be used. I cannot use those traditional proprietary technologies that I want to use. I'm thinking of some big data technologies to be used over here. Like I rightly said. Check it. Now, my dear folks, there was a big data problem that every particular organization started feeling. The post-social media era, the world of Orkuts and Twitters and Facebooks and LinkedIn. We know that over the last 15 years, we have been so much on this particular social media. And everyone started realizing that there is a lot of data that is getting generated, not only by these organizations, but the supporting organizations, the kind of enabling organizations and all of that. And what these organizations were doing with this data was they were not able to do anything with this data, and they coined the term called as dark data. Let me put that in double quotes. Any idea what is dark data? Beautiful term, dark data. Any idea? What is dark data? Again, you can Google it, search for it. System generated. Okay. Now, folks, the dark data was a term given to a data which was in the dark. The organizations were generating a lot of data, but they were not leveraging that for insight generation. They were not leveraging it for their usage. Like I said, we are here to build insights from our data. The organizations were generating a lot of data, but they were possibly sitting in silos, they were in different kinds of systems, but it was not getting leveraged. Imagine you are something like Amazon.com. There are lots of kind of customers visiting you. There's a lot of interactions that are kind of happening on your portal or on your app. But are you leveraging that interaction data to generate more insights and then leverage this to generate more business? If not, you are sitting on a dark data, the data which is not leveraged for your insight generation or for anything that can get your business better. And there were two reasons why was this data in dark, why the organizations felt that we are having a lot of dark data. We are data rich, but we are not insights rich. That was a terminology. We are data rich, but we are not insights rich. Which means we have a lot of dark data. We are not leveraging it. And there are two reasons behind it. The organizations were not able to leverage it because there are two things that you need from data perspective. And needless to say, we are going to focus on these two throughout the training. How am I going to store this data? How am I going to store this data? Where am I going to store this data? The data that is voluminous, having a variety, coming at a good speed to me. If I can store it, how easy it is to process this data, how cost effective it is to process that data. We know that, folks. Today, when we are sitting in 2024 and maybe a last 5 years or so, or a good 5 to 10 years, the data storage is never a problem. It has become cost effective. Today, you can store terabytes of data and still pay peanuts, I would say. Maybe a very small amount to store the data. The data storage is never going to be a challenge. It's not a challenge, at least at this point. Same as the processing. Think back 15 years ago. If I had to get some great processors, if I need a data processing to process maybe terabytes of data, exabytes of data, and petabytes of data, it was never easy to kind of have those particular processing power. But today, with the world of cloud, you can bring your clusters, you can create your clusters, which can help you process your data. Right? So the problem why we were generating a lot of dark data was a storage was not that cost effective, was not that easily available. A processing was kind of challenging and a very, very expensive thing to have. Now with kind of storage and processing becoming accessible, you kind of have a cost effective way, you are able to leverage that particular data, which is where we are talking about big data technologies being used. We are going to use big data technologies which primarily uses an MPP architecture. Again, folks, an acronym which is so important, and we are going to talk about it when I go to EMRs and Redshifts and many other services like that. So let's uncover this acronym. What is MPP?
Massive parallel processing.
Absolutely. A massively parallel processing framework or an architecture. We are not thinking about one single server. Now you can relate server to an EC2 instance. You're not talking about one single server who's going to process so much of data. How can I create a cluster, a set of machines, a set of servers, a set of EC2 instances who can parallelly process this particular data in a much faster way? Hadoop is a MPP architecture. Spark is an MPP architecture. When we go to AWS EMR, is an MPP architecture. When we go and build a Redshift cluster, it's an MPP architecture. The whole idea is how can I parallelly process that bunch of data? Now that's the big data problem. I've just kind of introduced you, given you some key terms of that big data. I'll take a pause again, asking you if you have any questions at this point of time. If not, then before I go and now relate this to AWS, the generic concepts that I've covered before I go to the AWS, I know you
Uh,
all would be waiting in a break.
Sanjay, this is Balaji.
Go ahead.
Just one question. So the big data technology in cloud will, I think you just mentioned a few services. So that is how we will leverage the big data technology.
That's right. So I'm going to now relate it to the cloud. What are the services? Like I covered in your uh, BI lifecycle, what are the different services that we have on the cloud? I'm going to now link it to what could be that services that we will leverage on AWS or maybe outside of AWS to work on those particular. So that was just a whiteboard that I was telling you that what's the world of big data according to you. Shruti is back as well. Thank you, Shruti. So folks, the first technology that caught everyone's mind was Hadoop. Now I'm going to go into the details of Hadoop. I'm going to talk about Hadoop, maybe at a later stage, too early to talk about that. But let me introduce you here and then map it to a AWS service. As I said, this is a session where I'm going to give you a breadth of things that we are going to cover and then go into the depth in every particular session when we meet. So I was talking about Hadoop, which is an MPP architecture to store and process big data. Now that we know what is big data, we know that one single server cannot store and process a lot of data. How can I have one server, let's say, storing exabyte of a data or terabytes of data or petabytes of data? And even if I store it, how are we going to process this data? It's going to take a lot of time. So Hadoop gives you a MPP architecture. Think of an MPP architecture as something like this. Whenever we think about the MPP architecture, a massively parallel processing architecture, so there is one master node. A master node is also called as a leader node. Some other technologies calls this as a driver node. Now, the concept is similar, that there is one node which is a master. It's like a project manager who doesn't do the work himself, but he or she would get the work done. So we would have data nodes. Hadoop calls it as data nodes. But if I talk about other technologies, it might call it as a worker node. Concept is the same. A data node or a worker node. Check this. Right? And you would have a multi-node cluster. I might have a 2-node cluster. I might have a 1,000-node cluster. This is a 2-node cluster. I've got 2 worker nodes, which means any job that I submit to a Hadoop cluster. What is a cluster? A cluster is a set of nodes trying to achieve something similar. So when there is a job submitted, the job is submitted to this leader node. Leader node doesn't do the work himself or herself. The leader node would divide the job into multiple tasks, give it to this worker nodes, 2 nodes or maybe 1,000 nodes. All of these will parallelly process the data, and then it would be sent to your master node, and the master node would then kind of summarize and send it to my client customer. That is a simple MPP architecture. And Hadoop was brought in to kind of create a cluster of nodes with Hadoop installed. It had 2 major frameworks: HDFS for storage, which we call it as a Hadoop distributed file system, Hadoop distributed file system, and MapReduce, which is for processing. So it has got the HDFS daemons and our MapReduce daemons processes, which typically is used in this particular architecture. I'm not going into the details of that at this point of time, right? Just giving you an overview as to how does this beautiful technology work over here. We've got HDFS and MapReduce. Now, slowly, this particular technology evolved. While MapReduce was good in processing, MapReduce had some problem. A MapReduce was doing a lot of disk I/O. Whenever a MapReduce was doing any intermediate results or processing any results and converting that to intermediate results, it had to write that results to a disk, which would need a lot of disk I/O. And that was little slower in the Hadoop as an architecture. That was little slower. So imagine you're processing a job and that job is producing some intermediate results, but every time you have to write that results to a disk, read it from a disk, which is what was making those jobs executing little slower. So obviously Apache Foundation, who's the founder of Hadoop, they had to fine-tune this particular architecture. And they got in another framework, which we call it as a Apache Spark. Again, I'm going to have a detailed session on Apache Spark, but just to introduce at this point of time, what is Apache Spark? It is in-memory processing. That is, we don't need to now write our intermediate results back to a disk, which is time consuming. You all know that, right? Whenever we write something to a disk, read something from a disk, it's slower. But when we write something to our memory in RAM, the processing is little faster. So Apache Spark was introduced with that intent. Now, there were lots of different things that were changed in Spark. I'm just mentioning you one at this point of time, and that is in-memory processing. And that was a kind of a winner. Apache Spark, with its benefits of being a unified technology, being a multi-programming, or I would say a multiple choice of programming options that you have it, in-memory option, a unified technology, it became a winner for most kind of organizations to use it as a big data technology. Today, if you are going to work as a data engineer And if you are going to work on the cloud, one of the things that you surely need to know is your Spark. Maybe working with Python or working with SQL is very important, because this is going to be a technology whenever we think about processing the data inside the cluster. Now that's about Hadoop and Spark. Now I've not gone to the details. I'm going to spend more time going into those Spark components and Hadoop components, and we're going to talk about it. Now that was the on-prem world. What was the challenge? I still remember when I started using Hadoop, maybe a good 10 years back, or a little more than a decade, I would say. And that point of time when we were creating a Hadoop cluster on-prem, just to create a single node cluster, forget about multi-node cluster, just to create that one single node cluster and create and kind of having all the configuration of a single node cluster, it used to take maybe a good amount of time, maybe a complete day, just to configure the cluster. Now, just not a cluster creation. Who's going to manage that cluster? Who's going to maintain that cluster? What about some of your machines or nodes go down in that particular cluster? What about fault tolerance? What about scalability? What about auto scaling? And you know what I'm talking about. Can I leverage my cloud to kind of provision these particular clusters and let the cloud take care of everything else? Creating a cluster, provisioning a cluster, making the cluster always available, fault tolerance, auto scaling, and maintaining all of that different things that I used to worry in the on-prem world, which means I need to be business focused. I'm here to process data in this cluster. I should only be focused on that. I need to perform some job creations. I should be only performing that rather than working about the underlying clusters. And there came a lots of services which we can use in the world of cloud. My dear folks, AWS EMR is one service that we can use over here, and that is called as Elastic MapReduce. Think of it as a managed Hadoop or Spark, which means don't think about creating clusters, provisioning clusters. That is just a 1-minute job. But you think about, how can I leverage those clusters to create my jobs? How can I write my PySpark code, which can do that different transformations, and all that cluster things can be taken care by AWS. So AWS EMR is exactly for that particular purpose. Is there any another technology that we can use it? It's there. You could use Databricks along with AWS, or I would call it as Databricks on AWS. Now, this is out of scope for this particular training, but since it is linked to AWS, I'm just telling you. So Databricks is an altogether a different platform, right? Which can be used for creating your data engineering workloads, creating data warehouses. Maybe it could be used by people from the data science background, machine learning. It's a unified platform for everyone today. Why Databricks? Databricks is by the same organization, or rather the same founders who had actually who founded Hadoop and Spark. So if you know the little story, the Apache Foundation, who founded Hadoop and then Spark, and Spark was such a popular framework to work with when it comes to data processing. The same founders of Spark, they left Apache Foundation, they parted, obviously for growth, and they formed a new company called as a Databricks. So Databricks as a platform, as a company, is formed by the same set of people who were the founders of Hadoop and Spark. And the whole intent of Databricks is that to create that revolutionary product which can be used by any data professional. to create that unified platform for any data professional. Now, what do I mean by any data professional? We know that folks today, data professionals have been working in silos. As a data engineering, you might be using some set of tools to work upon. As a warehouse developer, you might be using some other set of tools. As a visualization developer, you might be using some set of tools. There is another community called as a data science community who use their own frameworks and own kind of tools to work upon. Same goes with your ML engineers and all of that. So the idea of Databricks as a platform is that can I bring all the data communities, let it be data engineers, my warehouse developers, my SQL warehouse developers, let it be my machine learning engineers, data scientists, they get all of them on one single platform, right? And that is Databricks. But it's a smart platform. While Databricks is a platform that you can use it for all your workloads that I mentioned, Databricks doesn't have its own data center. Ultimately, we need to store the data somewhere, which I'm going to kind of process. I need some machines, clusters to process that data, which means I need infrastructure. Which means Databricks needs some storage devices, some storage equipments in their data centers. They need servers to process and all of that. And Databricks as a smart platform, it uses the public clouds. So Databricks created on AWS can also be used for the similar thing. You can create your workloads on Databricks on AWS, where your data might be stored in AWS and you could be processing in AWS, but the overall platform is provisioned by Databricks, making your job easier to work with. So that's a second platform that you do. Is there any other parallel technologies? For example, if I'm talking of other cloud, like I mentioned in the BI lifecycle, I was talking about other clouds who could do this. So on the Azure side, you've got Azure HD Insights, Hadoop Insights. You've got Azure Synapse, which also can be used for creating Spark pools and creating that kind of workloads. Azure Databricks, again the same thing. So on the Azure side, you have all of those parallel technologies which can be a cloud technologies to kind of process your big data. Needless to say, our focus for this training is going to be this particular service. I'll take a pause, folks, if you have any questions at this point of time. Any questions? Good to go, Brahma says. What else? Anybody else? Hadoop and Spark and on cloud. EMR. So I want all of you to remember these services. Elastic MapReduce is something that we are going to spend some time. Okay. If that's clear.
EMR is a replacement of Spark, or it is Spark is working with the EMR?
Sorry, come again. What is that? Sorry.
EMR is similar to the Spark, or Spark is working with the EMR?
So EMR is actually just a service which can provision your Spark clusters and you can run your Spark workload. So it is Spark only, but instead of you manually creating those clusters, now you can kind of quickly create your clusters and run your workloads without thinking about managing and maintaining those particular clusters. So it is Spark and Hadoop, which you can configure it over here. So let me just show this to you. If a little hands-on at this point of time helps, let me show this to you. At least you will have a remembrance when I show you this. So let me take you to the AWS world. Let me log in. I have not logged in from the morning. Let me log in. What happened to this? Internet looks good. So let me log in. I'm going to use the root user login. It should be okay. Here we go. A verification code sent. Just retrieve that. Okay, receive the verification code now. Sometimes these multi-factor authentication could be delays. Received it now. Here we go. So just to show you folks, so that you remember these particular services, we are going to see that in details, but just kind of have a breadth of these services today. EMR. Now I can always read these one-liners. I love these one-liners. There are hundreds of services. Obviously, the data services are not hundreds, but in AWS, you have got hundreds of services. Look at these one-liners to see. That's what I was saying. EMR is a managed Hadoop cum Spark framework or other service, which means you just kind of provision your clusters, let everything else be taken care by AWS. You think of running your jobs. Now, when you go to EMR, and I kind of create my EMR cluster. Let's say I'm going to create a cluster. I'm not going to create a cluster, but just to show you. Look at this. All of these kind of Hadoop elements can be provisioned. Let this get loaded. You will see an EMR release and you will see all the Hadoop services that you can kind of provision it on your cluster. Spark is just one of them. Look at this. Spark is just one of them. But can you see that all the Hadoop, if anybody comes from a Hadoop background, I've not gone to the details, but there are lots of services of, or rather lots of components of Hadoop framework, which we call it as a Hadoop ecosystem. You can kind of just provision it by using this EMR as a service. For example, you want a Hive to be installed and configured. You want Hadoop to be configured. You want Spark, obviously, to be configured. You want, let's say, a pig as a ecosystem component to be configured. All we have to do is just kind of click all these options, give certain options, and go ahead and create a cluster. And on this cluster, I can go ahead and kind of run my EMR jobs. So ultimately, you are creating EMR. I mean, you're creating a Spark cluster, but EMR eases the work for you by so that you can only focus on your business rather than thinking about clusters and infrastructure at this point. That hours of cluster creation now is reduced to few minutes. Few minutes. Trust me, in few minutes, you can have a Spark cluster up and running and you can start running your kind of your Spark jobs. Does this make sense? A little clarity on the question that you asked? Make sense? Okay, wonderful. Now I move on, folks. And I'm sure some of you were waiting for it. The time has come now. Folks, we were talking about data lakes. Somebody was asking me, Sanjay, where are data lakes and where would data lakes come into this particular picture? So let's uncover that. What are data warehouses? Or a data mart is the another name that I gave it to this. And what is data lakes? And there was another term also, which we called it as a lakehouse. Let's talk about it at a little later. Now, data warehouses is something that we were using when we were only thinking about relational data, or in short, a structured data. Go back to my traditional BI lifecycle. Here, I was only thinking about creating a relational Oracle or SQL Server or Teradata. I'm thinking of creating my relational data store. That is a data warehouse, structured data. In short, it's a relational data store. In other words, this is not a data store for transactional data. This is for analysis. So I call this as analytical database. One of the things that you have inside a data warehouse is, because it is relational in nature, the data integrity is guaranteed, or it promises a data integrity. Why? People who work with relational databases, we know that we write so many constraints. There's a primary key constraint. There's a foreign key constraint. There is a not null constraint. There is a check constraint. We write transactional data and transactional code to ensure that that asset compliance is always there. Remember that asset compliance. Sorry if I'm using an acronym. Not everyone might know about asset. Anyone, folks, what is an asset? I'm sure some of you come from a data background. This is the basics. What is asset? Write that for me in the chat box. Asset. Asset from the database perspective or RDBMS perspective. What is asset? Yeah.
It is atomicity, consistency, isolation, and durability. When a transaction, suppose
Absolutely.
when we withdraw the amount from the ATM, if
Mhm.
the transaction is fully updated and confirmed, received that the confirmation, then only cash will be released. Otherwise, it will be declined. That is the
Absolutely.
asset rules.
Absolutely. So good example to take it, right? So it is reliability is what we are promising over here. Not just to tell you what is asset. Asset promises you a reliability. Asset means atomicity, consistency, isolation, and durability. Like the example you said, only when you have a amount withdrawn from the ATM, all the kind of checks are done, the complete amount is kind of debited from the account, all the kind of things have taken place, then only you will have the money in hand. Now take an example. I am transferring some money from an account A to account B. Say I'm transferring it from one person to another person. What if the amount gets debited from account A, but it never reaches your account B? Is that a reliability? Is that a consistency that I'm talking about? No. So the asset compliance gives you that reliability, that a transaction is only committed if all the operations of the transaction are completed. That's what asset compliance promises. And RDBMS is primarily for that. Needless to say, because it's an RDBMS technology, it is expensive. compared to what we see inside your data lakes. Now, folks, we know that data warehouses have been great in kind of working with this. But data lakes is a modern day data repository that we may want to create it at times. Unfortunately, a data warehouses were meant for only structured data and the relational data that I was talking. But did we not speak about that today? We can have variety of data. What if I have a semi-structured data to be stored? A JSONs, an XML. What if I have a structured data also to handle? And then maybe unstructured data also to a certain extent. So what if I have to do that? Unfortunately, a data warehouses cannot help in that particular regards. But on the other side, so data lakes can help you with any kind of a data. But on the other side, since we are talking about any data, this is not kind of enabled for transactions because this is quite low on data integrity. Don't expect an asset compliance here. But on the other side, it is quite cost effective. If there is anything cheap to store the data, it is your data lakes. Warehouses on the other side, because it uses your relational RDBMS and relational technology, they're little expensive to kind of implement over here. Data lakes are simple to implement, cost effective, and they can be quickly created. So remember data warehouses versus data mart. Now look at this, both have got their own advantages and drawback. Data warehouses are good for reliability and data integrity. Data lakes are better because it can handle a variety of data and it is cost effective. Both have got their own advantages. One more thing kind of to look into it, and which is what I want you to remember here whenever we come across a data lakes. Soon, tomorrow, I'm going to show you that. Warehouses are schema on write, or any RDBMS for that matter is schema on write. Data lakes on the other side, they are schema on read. And I'm going to highlight that word schema on read so that you can remember this and I don't have to spend a lot of time explaining at that point of time. Can anyone tell me what is schema on read? Anyone?
It's like one time writing, reading multiple times, easy reading of the written data.
Okay. Any other answer? Schema on read.
It is applied only when it is read, and not probably when you're performing any updates.
Okay. So look at this, folks. When you create, I'm going to ask you a question and this will make you clear. When you create your RDBMS data, or rather when you have your RDBMS data, what do you do first? Do you first create a table and then
first we create the
insert the
schema
data?
table, but in the data lake we don't need the schema to write. After write only schema will be.
Absolutely. That's the most important difference between the two. In the RDBMS, we first create a table. People who have worked with RDBMS would know. If you don't know, let me tell you. We first create a table schema. We say, hey, create table employees, employee ID is an integer, employee name is a varchar, gender is a varchar, and so on and so forth. You first build a schema. Without schema, you cannot think about inserting the data into this table. After your schema is built, then you say insert into employees, values these particular values. Second record, insert into employee, values these particular values. That is how you perform your data writing inside your data warehouse. It's a schema on right. But in the data lakes, because you get the data into any format, it's a variety of data. So the concept of data lakes is whatever is the format, simply write to a object storage or a data lake. You just write it. Say you have a CSV file that is having a data. Simply write to a data storage. So object storage or a data lake. You have a JSON file, right? You have a CSV file, right? You have an Avro file, right? But now let's say if I ask you, hey, now can I go ahead and write some SQL queries on this particular data? Let's say I have a CSV file. Can I write a SQL queries on your data? Hey, have you gone mad? How can you write SQL queries on the CSV data? How can a CSV files have, you can write SQL queries. The SQL queries can only be written on something which has a schema. On your warehouses, on your data marts, on your RDBMS. But data lakes enable you to write queries, to perform querying, to perform analysis by writing queries on it, as if you are working with warehouses, as if you're doing analysis in warehouses. And how does it do it? Sorry. How does it do it? It does that by writing a schema or creating a schema based on reading the data, which we call it as infer schema. Sorry, folks. So we infer the schema from the data, and that schema then helps us in querying. That's the main difference between the two that we are going to see. Now let's look at traditionally how are we implementing this. We know that traditionally I already spoke about that in the BI lifecycle. You are using Oracle or SQL Server Parallel or Teradata. But in the cloud, we use technologies like Redshift, services rather I would call it as, Snowflake, Databricks, Azure Synapse, Google BigQuery, all of them can be used to implement your data warehouses. Obviously, from our perspective, Redshift is what we are going to see. But what are the different AWS services that can help us in building our data lakes? So folks, data lakes, storage, and processing. We have got HDFS. We can have our data into Hadoop. Even that can be considered as an object storage or a data lake. More convincing, if we are from the world of AWS, why would I think about HDFS? Can I use my AWS S3? The first service that we are going to cover from a data perspective is S3. Think about an S3 as an object storage. Think about S3 as being a kind of a data lake where I can land all my data in different varieties. We are going to use then a service called as an AWS Lake Formation, which can help us in creating secured lakes. Ultimately, you're going to store the data in S3. But how can you create more secured lakes? AWS lake formation comes into picture. We said from the lakes, we are going to infer the schema, which means, let's say I've got an employees.csv file, and now I want to infer the schema of this employees.csv file. But how would I infer? And where would I store this schema? I've got a service called as AWS Glue data catalog for schema, inferring the schema as well as storing the schema. How am I going to query that data? I said even you can write SQL queries or interactive queries on a simple data lake file. And for that, we have got a service called as an AWS Athena. Think about Athena as an interactive querying service. Are we going to cover all of that? Absolutely all of these services you are going to see in the upcoming sessions. S3, lake formation, AWS Glue data catalog for schema building, AWS crawlers for crawling the data, AWS Athena for interactively querying that particular service. Now, understand what do I need in AWS to implement a data warehouse? Our focus is going to be Redshift. What is required to implement data lakes? You need all these particular different things to be worked together to work with data lakes. I'll take a pause before I introduce a word lakehouse, but I'll take a pause in case there are any questions. This is an important one, so let me take a pause. Come on, folks. Pause, pause, pause.
No, I understand S3 is for storage, data storage. The lake formation is basically will help us to create a data lake on AWS. Is that what that service will do?
Wonderful question. Wonderful question. So like you rightly said, ultimately you will be storing the data inside S3. But let's face it, S3 is not just for data lakes. S3 is a plain object storage of AWS. So how do I create secured data lakes? For example, what do I mean by secured data lakes? There are multiple aspects to it. Imagine we have got a S3 bucket and I've got multiple buckets in my S3. Is that every bucket is my data lake? No, I might have created some other buckets for some other jobs, some other workloads. Is every bucket to be qualified as a data lake? No, I may want to kind of put in what kind of buckets and the paths within that bucket qualifies as a data lake. Number one. Second, does everyone has an access to my data lake? No, I may have only few roles, users who would have an access to data lakes. Third, if they have got access, am I going to give all the access? Read permission and a write permission and other permissions? What are the permissions that you need on that particular data lake? And all this what I spoke about, the configuration of data lakes in an easy way, securing your data lakes in an easy way, and managing that data lakes with one single console is a service called as a lake formation. So I can create data lakes without lake formation also. But then I would have to navigate to different kind of windows, different services to create a data lake. And I might not be still able to secure it. But lake formation gives you that one single unified interface from where I can create data lakes, manage permissions of the data lakes, secure my data lakes, and do anything else that I want to do with from the data lakes. Does it answer a query? At least at this point of time. We have not gone into that.
Yes.
So
Sanjay, thank you.
Yes,
Now,
please.
leading to that, I know you mentioned in the S3 storage bucket, you can mention what constitutes a data lake and what is not, right? I believe when we use that service, you can probably show us that? How do you use it?
Absolutely. I'm going to use that particular service and I'll show you what configures a data lake. I'm going to give you a demonstration also.
Okay, great. Thank you.
I'm going to do that. So folks, don't worry. If you're thinking about details, I'm not gone through it. All I'm doing is I'm doing a concept creation so that you know these data lakes concept and data warehouses concept. And then I'm linking it now so that you know what is coming next in our future sessions. Have I gone into the details of it? I've not gone into the details of that session, which is where I said this is a foundational session that I'm kind of giving you. Thank you, folks. Thank you so much.
Sanjay, one
Hey,
more question.
yes.
I know we are getting introduced to all these services. Is there one place where we can remember? Because these ones, I mean, it may be hard to remember. I know we can go to the console and type AWS Glue and probably we can remember. But do you have any tips of how to remember these services and for what purposes they are used?
See, what I would suggest is the whiteboards are going to help you a lot. The reason for creating these whiteboards is I don't put a lot of details on the whiteboards, but at least they will help you remember what this particular service is and where do I link that. If not, I think I have one presentation where all the data services are there in one presentation. I can kind of share that presentation with you and that will give you easy access.
Yeah, okay, that'll be helpful. Yeah.
I'll do that. Now, folks, somebody said, what is a lake house? Data warehouse, we are aware of it. Data lakes, we are aware of it. What is lake house? So as I would have answered already, you might ask me, Sanjay, what is better? Is data warehouse better or data lakes is better? So folks, it's nothing that a data warehouse wins over data lakes or a data lakes wins over a data warehouse. It is the need that you have it. It's a scenario that you want to implement here. There are cases where you might want to implement a data warehouse because you are looking at asset compliance. Data integrity is important. There are scenarios where you might feel data lakes is the right thing to implement. I am not worried about data integrity. It's all about data reading and all of that. But if you ask me, we try to be greedy, right? We always want more. Sanjay, is there any way we can get both? In short, can I get the best of two worlds? In the sense, can I get something which is giving me data integrity, reliability, asset compliance? On the other side, it is kind of can have any kind of data and it can also be cost effective. Is there anything that can help me? The concept of lake houses comes into picture. Now, do we have a complete lake house in AWS? We don't have. So the word lake house was brought in by Databricks. Databricks bring in a concept of lake houses. It's a lake house platform. And what it calls its lakes as a delta lake. Just like we are calling it as a data lakes, they call it as a delta lakes. What is a delta lake concept? The idea is, how can I have my data lakes have that reliability and asset compliance? That is a lakehouse platform. Do we have a complete lakehouse platform in AWS? No. But Databricks bring you that lakehouse platform concept. So I'll show you. If you go as Databricks, let me go inside this. Understand, folks, if you just go to databricks.com, I did tell you that, it's a unified data intelligence platform for everyone and all of that. Right? It is to unify all your data. You are a data engineer, warehouse, you are an AI engineer, ML engineer, all of that comes into one single place. The idea is that Whether you are an ETL engineer or you are a SQL developer, you want to build warehouses, you want to orchestrate, it's the same platform for you. If you go down, you will see that particular lakehouse concept. It's that lakehouse. Let me bring in that lakehouse for you. See this. The idea is, how can we create delta lakes, the lakes which are having data lake reliability underneath. That's the concept of your lake houses here. Can we create complete lake houses in AWS? No. Then for that, you have to use your Databricks on AWS, which can bring you that lake houses. That's the concept, folks. If you were thinking what are lake houses, I'm going to save that. Call this as fourth whiteboard, DWH versus DL, and maybe versus lake houses. Understand? Folks, moving on. Now, largely, I've been trying to cover the services that we are going to see, that you are going to see me implementing all these services, Athenas and Glue data catalogs and AWS S3, and maybe building lakes, secured lakes using kind of lake formation and Redshifts and all other services that we saw in the previous slides. But now the next few slides, I also want, before I go to the storage services of AWS and we start spending some time, some concepts which, let's cover this as a prerequisite before we start implementing it. Some of you may know it, people especially who come from the data background, they would be knowing about it. But let me kind of go ahead and cover this. And I'm talking about a pure play modeling concepts. So first, talking about a data modeling. A data modeling is a kind of a area where you build your data models with the details of data and the fields and the columns to put inside that particular data models. Not just that columns, you put your relationships and everything else. Now, some of you would already know there are three phases of a data model, or three types of a data model is what you can call it as. There's a conceptual data model. There is a logical data model. And there is something called as a physical data model. Anybody wants to guess what these three levels of data models are?
Conceptual is a high level design of the all the entities information connections. It will not show the detailed entity information attributes and all the information, only the entity level it will. Logical
Absolutely.
logical
Okay.
is
What?
a platform independent, and here we have complete information about the table name, column name, and null categories and the primary keys and the unique keys, natural keys, everything,
Wonderful.
relationships and model designing like a star schema, snowflake schema, all will
Wonderful.
be this is. And physical model is a platform dependent. Once we generate from logical to physical, it will be executable into one particular which we choose the Redshift or Oracle or Teradata, whatever. It is
Yeah.
executable into the platform.
Lovely. I think lovely explanation. Couldn't have kind of done better on that explanation. So to put it simple, think of a conceptual model as a concept, if you want to remember. High level. In short, no details. Forget about implementation details. No details. No implementation details. Don't think about a tool or a platform or anything that you're doing. In short, it's all abstracted. For example, if you are going to create a data model for a sales warehouse, you will just think about your entities. Like customer is your entity, product is one of the other entities, product category is another entity, subcategory is another entity. Maybe you will have sales data, sales table, or a sales entity, and so on and so forth. Geography is another entity, and so on and so forth. So you're not thinking too much a fine grained, two level, two kind of going into the second level, like columns and data types of the columns and relationships. You're not thinking about all of that. It's conceptual. In short, you're identifying your entities in. That's a advantage of creating a conceptual data model. You'll first identify what are your key entities when you are building a data model. You then go next level and you create a logical data model. So in the logical data model, you kind of go ahead and define the data structures. You go fine grained now. You still don't think about the implementation, but then you think about what are the attributes, columns of each object or an entity. Like, think about, if I'm thinking about the above entities, then what would customer have? A customer would have customer ID, name, and so on and so forth, address, gender, whatever you can think of. What would product have? Product ID, product name, product description, product price, product cost, so on and so forth. Model, SKU, whatever. What would category have? Category ID, category name, so on and so forth. So you think about the details. How are these tables related? Like, we got the answer. How are the tables related to each other? You think about it. It's still logical at this point of time. So most likely when we create a data model, first the conceptual data model is just to identify the entities, but the logical data model is the one which typically you create to get your complete understanding of the data model. You may have not gone into the implementation, like, am I going to implement this in Oracle? Am I going to implement this in SQL Server? But you have a clarity about how does your data model look like. And the physical is now going into the implementation side. You implement, there would be a platform dependence that would be required here, right? So you go into the implementation. Which means now you'll think about, if I have a customer, now I won't call this as an entity. I would rather call this as a table. How are you going to implement this? Say I have a customer ID to be implemented. What would be that data type which would be used in that technology? For example, I'm using Oracle. I might have a different data types than the SQL Server. Most common data types would be there. But I want the customer ID to be unique. So how can I make it unique? Am I going to implement a sequence in the concept of Oracle, or am I going to create an auto-incremented column? Think about how are you going to implement it, which is what I said, get into the implementation details. So logically, we start with the conceptual model, identifying the entities, detailing the entities, and then implementing the entities. That's how the concept of data model arrives on me. Now you would see me often working with logical data model and the physical data model when we go into the implementation. So remember that simple concept, no big deal about it. I'm going to just save this for your reference. I'm going to call this as data model. My dear folks, one more board which is must for working with data models. Let me bring that on the another whiteboard. Again, most folks from the data background would know. I would want others to kind of remember this. This is such an important piece that I'm working upon. I'm talking about a dimension modeling. Right? I'm thinking about a dimensional modeling. The dimension modeling is used for warehouses, data warehouses. Right? Data warehouses scenarios. Now, first simple concept. What is dimension modeling? It is used for data warehouse scenarios. What is a data warehouse? You're bringing in all your organization's data and you are then creating tables where you would have your data. You would have fewer fact tables. A fact table is a transactional table. Say I've got a table called as a fact sales, where I'm bringing all my transactional data. But I might have other tables. For example, I might have a table called as dim date, or let's say a dim geography, or let's say a dim product, or let's say a dim customer, or let's say some other term tables. Let me not talk about at this point. So I might have a dimension table, which I call it as a master table. Say I've got a dim date table, where I'm having all my different dates and different calendar dates stored inside this table. Very important for any warehouses. You need to have a time series information. It comes from the master data comes from dim date. If my business is in multiple geographies, I might have a geography table where I'm storing all the geographical locations for my business. Say I'm dealing with a retail business, I might have the products information. I'm going to call that as a dim product. I might have a dim customer table, which is for my customers over here. I call that as a dim customer. Check. And then obviously these tables are connected to each other. You would have some kind of relationships between them, a primary key, foreign key kind of relationship that gets over here. And when you create these kind of relationships, we call this as a dimensional model. And any idea what is the schema called as, what I've drawn over here? Sure. Most people would know. What's the schema called as? A star schema. Absolutely. What is a star schema? You have a fact table in the center, and then you have dimension tables which are directly related to this fact table. So I have a dim geography connected to this, dim product connected to this, date connected to this, customer directly connected to this. It is actually a star schema what I've drawn. But what if I have few other dimension tables which are not directly related to a sales table? Say I've got a table called as dim product subcategory. Or maybe a table called as a dim product category. So I've got a table called as a dim product category. And obviously, if I have these particular tables related, it would be related like this. You would have a table related. It's not a star schema now because I have now a dimension table which is not directly related to a fact table. It's not directly related to a fact table. It is connected via another dimension table. There's an indirect relationship to a fact table. Similarly, this particular category table is not directly connected to your fact table. It is indirectly connected to this fact table. I've already got an answer by Mama. This is called as a snowflake schema. So just giving you the concepts. We might work with a star schema or we might work with a snowflake schema. We'll see The examples when I build my own warehouses in Redshift, when I create my data lakes, I'd show you basically a star schema versus a snowflake schema. But one more concept within this dimension models. Obviously, these are tables. And the tables would have fields, columns. And the fields can be classified as either facts, which we also called as measures, or it could be dimensions. What's the difference between a fact and a dimension, or a measure and a dimension?
Right.
Yeah.
Yeah, fact is holding an aggregated data. Dimensions holds a master data kind. Even dimensions also we can use the CDC, change data capture, like concept 1, 2, 3.
Okay. Okay.
Uh, yeah, this is it depends on the model, Snowflake or Star. Dimensions
Okay.
usually contains the master data. That is this all is coming from the OLTP. This is the OLAP concept aggregated for the visualization purpose to generate the reports.
Wonderful. So put it this way, folks, the facts and the measures that we are talking about. As the name suggests, a fact or a measure is something that you want to measure. You want to measure something. You are interested in tracking. You are interested in monitoring, measuring. If I work with a sales scenario, since I've taken a sales scenario here, my measure could be my sales, or you might call it as a revenue, or a profit, or the number of orders, or number of customers, so on and so forth. All these are my measures. And they would be ideally, these measures would be available in the fact table. So you might have a sales and a profit in the sales table. Ideally, you'd have these measures created here. You'd have sales and a profit available in the fact table. Right? But dimensions are the way that you measure something. How do you slice dice your data that comes from your dimensions? So if I want to measure sales, I might want to measure it by multiple perspectives. I may want to measure sales by region. I may want to measure sales by, let's say, product. Which product is giving me what kind of sales? I may measure sales by geography. I may measure sales by year, or a month, or a week, or a day. I may measure sales by category. Which product categories are giving me what kind of sales? So if measure is a metric or a measure or a fact, all of this qualifies as your dimensions. These are your dimensions that I'm talking about. And they would primarily be available in your dimension table, the data of that. The region could be in the dim geography table. The product could be in the product table. The geography could be in this geographies table. Year could be in the date table. Category could be in this dimension tables. So what do you want to track? What do you want to measure? Those are your key metrics of your business, facts or measures. But how do you want to measure? How do you want to slice and dice your data? That would come from your dimensions. Now we are going to use this when I go inside my QuickSight. I give you a demonstration of QuickSight. When I go to Redshift and bring that particular dimensional modeling, those two concepts are very, very important to kind of. I'm going to save this for you. Let me call this as dimension model. I hope it's clear, the simple concepts over here. I'm now going to take you to, if you ask me now, the foundations, basics are done. Something that you have to remember, the 5 or 6 whiteboards that I'm now going to start with the actual services of AWS one by one. And the first one to start with, the first one, at least to get you an understanding of what are the different services that we have in the storage area. What are the different storage services that we have in AWS, and when to use what is something that we are going to uncover. So I'll need 2 whiteboards for this and see all the options for storage of data. The first and the foremost, if you come from an AWS background, if you implemented EC2 instances, I'm sure I heard from Sumti as well as some of you that in the previous sessions you had an EC2 instances that you covered. EC2 is a virtual servers that you create, a virtual machine or a VS, that virtual server that you create, a Windows server or a Linux server or an Ubuntu server and all of that. Now, if I want to store some data on the EC2 instance, we create, or rather we associate something called as an EBS volume. You would know this. There's an EBS volume. What is an EBS volume? Think about it as a disk on your machine. You have a laptop. On the laptop, you have a hard disk. And that hard disk stores all your data of your machine. But in the world of cloud, you have an EC2 instance which is linked to this particular EBS volume. And they are loosely coupled. You can detach this EBS volume. You can attach it, this EC2 instance, attach to this particular EC2 instance, or detach and attach it to another EC2 instance, quite possible. So EBS volume, think of it as a logical volume, a random access memory, a block storage which is used for your EC2 instances. But I have a question for all of you. Can I have an EC2 instance having multiple EBS volumes? Can I have 2 EC2 volumes or maybe multiple EBS volumes, attached to this EC2 instance? Is that possible? Is this scenario possible? Think logically. EBS volume is like a hard disk. Can I have multiple EBS volumes attached to an EC2 instance? Think logical. Yes, folks. Possible? Not possible.
Yes.
Absolutely possible. You can have multiple EBS volumes. If at all you work with EC2 instances, when you kind of provision your EC2 instance, there's a kind of a option where you can say that, hey, you can attach multiple EBS volumes to an EC2 instance. Quite possible. It is absolutely possible. But if I ask you this scenario, I've got another EC2 instance as well. I've got another EC2 instance in AWS and another virtual machine or a server. Can I have the same EBS volume associated with 2 EC2 instances? Meaning this EBS volume is associated with this EC2 instance as well as this EC2 instance. Possible, not possible. Come on, folks. Possible, not possible? Guess would do. You don't have to be logically right. So Balaji says not sure. Now, while it is possible, indirectly possible, it's not directly possible. Think, why do you want to have two EC2 instances attached to the same EBS volume? Why do you need that? Why do you need that? You might need it because you want some shared data. You want some data that is being shared by multiple EC2 instances. So AWS says, hey, this is not the right way. I'll give you another service. And that is called as an AWS EFS. Right? So the first storage service, which often you will hear with respect to EC2 instances, is called as EBS volumes. The second one that you have it is AWS EFS, where you can have your multiple EC2 instances mounted or attached to this particular service. So what is EFS? Think about an EFS, an elastic file storage. Elastic file storage. This is that network share. If you work on your on-prem environments, don't your organizations create some network share? Which can be mounted to multiple servers, laptops. Think of it as a shared storage. All I want, because I want multiple EC2 instances to attach to my storage, I need some shared storage. In short, they implement an NFS protocol, network file sharing, or SMB protocol.
What is
So
the
that's
difference between the EFS and S3?
Yeah, I'm exactly a pointed question. So let me show you what is S3 over here. I'm exactly going in that particular scenario. So far we are talking about two storage services, EBS volumes, which can be attached to your EC2 instances, and EFS, which can be mounted to multiple EC2 instances from sharing perspective. Think about it as a network sharing. Now that we know EBS volumes and EFS, my question to each one of you here is, what's the problem with both these services from the storage perspective? What do you think is tedious, tricky, not so easy to work with when you think about storing something in EFS and EBS volumes? Any guess? Something that is common. You can look at the commonality between the two. What's common? Come on. What's the commonality between the two?
Virtuality.
Virtuality. Okay. Folks, in both cases,
We are sharing
if you
resources.
want to access, sorry, what is that?
In both cases, we are sharing resources, right?
Okay. In both the cases, if you have to access the storage, whether it is EBS volumes or it is EFS, I need EC2 instances. Here
Right.
also I've got the EC2 instances which are attached or they are kind of mounted here. Here also I've got the EC2 instances mounted to the EFS, which means they are dependent on EC2. Can I not rather have a storage which is independent in nature. I don't need EC2 instances to access this data. It can be accessed from anywhere using some kind of object URI, or a URL is what we call it as. I can use my REST API to access that particular object. And there comes the most important storage, the most commonly used storage of AWS, or why AWS, any clouds, you would see this is the most common storage. We call this as an object storage. And what comes under object storage in AWS is a S3. It is a simple storage service of AWS. So first thing, it's an independent storage, unlike the left-hand side. You don't need EC2 instances to access S3 or any object, anything that you store inside it. No EC2 to access the storage. Point number one. No mounting required, like you see on the left-hand side. And the best thing is that this is the most cost-effective storage. If there is something cheapest, cost-effective in the storage form, that has to be S3 or any object storage. Now, why is that so? As I said, this is an object storage. What is an object? The word object means anything can be an object. For example, can a file be my object? CSV or a doc or a, let's say, a Avro file or a Parquet file or any such file. Can I have an image as an object? JPEG or PNG, whatever. Can I have a video as an object? MP3 or a MP4 or a WMV? Can I have some code that I'm writing? It could be a .js code, it could be a .cs code, .java code. Can that be an object? Or an HTML code can be an object? Anything is stored as an object. Now you understand the relevance of data lakes. Why was I saying that a data lake can have any kind of a variety of data? That's because what defines your data lake behind the scene is your object storage. I store anything as an object, which is where object storage is what is used for implementation of data lakes. I said that you can independently access the data. You don't need EC2, which means it can be accessed like, you access it through a browser using some address, some URL. So we use a REST API. You will have a URL or a URI is what we call it as, to access any object. Any object has an individual URL and URI to access it. All these objects, any cloud, whether it is AWS or Azure, they promise 99.999, sorry, 999% durability. It means that once you store the data inside S3, there are hardly any chances that you're going to lose that particular data. The example of AWS says that if you're storing 1 million files, 1 million objects to be very precise, and you're storing it for 1 million years, we are just in 2024, I'm talking for 1 million years. If you store 1 million files, you're just going to lose one single file in that 1 million years. 1 million is 10 lakh years. That's the kind of a durability that these particular services promise. Now, needless to say, how's that promise made? That promise is made with respect to redundancy. The data is made redundant. We try to replicate the data. Very important. So we talk about it when we go into S3, that replicating the data. How do you replicate it? What are the different access tiers that are used in S3? But the fundamentals is it's the most durable storage to have it. Lastly, there is a support for versioning. I can have multiple versions of the data of the particular object store. And which is where these object storages can be used in multiple scenarios. For example, can I use S3 to behave like your code repository, something like a GitHub and GitLab? Yes, it can have an object, code as an object, and then it can support versioning. Can I use it like my code repository? Can I use this to host my static website? We know that to host a website, you need a web server. But because we can host simple files and I can enable versioning, I can even host a static website inside S3 without having my web server, without having any cost of my web server. And that's the power of the object storage. The concept is simple, that this is the independent storage. Anything is an object, and it kind of gives you the durability and a versioning that you needed for any kind of environment. So the third service that we are talking about, let me go ahead and put this, is S3. So this is storage part 1. Let me save this for you. I'm going to save this, this is my 7th whiteboard. Storage services part 1. We are not yet done. But then you're going to ask me, Sanjay, so all this is good. But what if I have some more requirements over here? For example, I want to store now and relational data. RDBMS on the cloud. I don't want simple files to be stored or images to be stored or objects to be stored. I have a relational data which I can query, perform my CRUD operations, that is create, update, delete operations. How can I use AWS over here? Or is there any service that can help me here? Folks, the answer is you then have something called as AWS RDS, a relational data store. Sorry. A relational data store which supports multiple database engines like Oracle, SQL Server, MySQL, Aurora DB, and many in this particular format, folks. So if your kind of thing is to work with RDS or relational data space, then you have an offering of AWS RDS to rescue over here. You might say, if these days we move to the world of NoSQL, so this is my fourth offering, a fourth storage that we are going to use it. Are we going to use it? Yes, I'm going to show you in multiple forms how do you use your RDS. And obviously, this would be used in many of our services like Glue and all of that. The fifth offering.
Sanjay, just
Go ahead, please. Go ahead, go ahead.
the AWS RDS, it supports RDBMS, right?
That's right.
Now, where the storage happens, that also takes care of the storage.
Yes, it takes care of the storage. So RDS has got its own proprietary format. It is not S3, which typically stores the data. It has got its own. Obviously, there is an object storage behind the scene, but it is not S3. But it uses its own proprietary storage, just like any other kind of formats. As I said, there are multiple database engines. So if it uses Oracle, it uses an Oracle type of a storage format. If it uses SQL Server, it is a SQL Server format of your storage.
Okay,
Now, what is
so
RDS? Yeah, go ahead, please.
we can't use S3 then in this case,
No,
right?
we cannot use S3, which is where I said it's not S3 in this particular case. So it is proprietary to what's the kind of a technology we're using. So think of RDS not from storage perspective. Think of RDS as relational database as a service or database as a service. Instead of creating your database servers on-prem, you are now creating some kind of servers on the cloud without having a headache of managing and maintaining.
Okay. In other words, the same product which we do on premises, same we are getting from the cloud, right?
Absolutely. What you're doing on-prem, you're now able to use it on the cloud without having a kind of a management overhead and
Yeah.
all of that
Oracle
is
license and creating the schemas and all. Only
absolutely,
depends on the requirement, will go and occupy the space and we pay for it.
absolutely. So no need of managing the servers, licenses and everything, all of that. You would just be having a pay as you kind of a database server, which would be deployed in few minutes. And you can create a multi-AZ kind of your database server in few minutes. That's the power of RDS.
Okay. And we don't need to create EC2 instances for this.
No EC2 instances. If you're creating EC2 instances and then on top of EC2 instances, if you're installing Oracle, that is not RDS. That is still our responsibility. The only thing is instead of installing on my physical server, on-prem, I'm installing it on virtual server. Is that RDS? No. That is still an infrastructure as a service. RDS
Okay.
is a platform as a service where whatever we do on-prem, we are now provisioning it as a service on the cloud. No EC2 instances management. Absolutely right.
And then how does the migration work? Like, I don't know if you're going to touch base. Like, let's say an organization the on-prem Oracle
Wonderful.
database or
So there is a service called as a DMS, AWS DMS, which is not a data engineering service. It's a pure play migration service. But there is a service called as a AWS DMS. It's called as a data migration service that can help you in migrating the data from on-prem to cloud, one cloud to another cloud, one particular database to another database. It can help you in that particular service. DMS is the service. Make sense?
um, I
Wonderful.
mean, it makes sense, but one thing is, I just want to see how this RDS is being used. When you migrate, you will migrate to this, or I don't know how RDS will access that migrated data and supports querying upon it.
So I'll show you the RDS. Maybe tomorrow we are going to kind of build up the RDS server. So you can ask
Okay.
me what exactly you're looking at and I'll answer that. No problem.
All right.
Let's see that. RDS implementation, we are going to see that. Yeah.
Okay.
No problem. Then the next thing that comes into picture is NoSQL. There are times now we are not just working with SQL databases. We are working with NoSQL databases. Now, if you're new to this world, don't worry. As I said, everything we are giving is I'm just giving you a breadth of services that we are covering. So NoSQL is a different world. NoSQL doesn't mean NoSQL. It is not only SQL. Today, organizations, because of the volume of data, variety of data, velocity of the data, they have been moving from relational databases to NoSQL databases. There are lots of NoSQL databases that we have today. Like if you've heard of MongoDB, CouchDB, Cassandra, GraphDB, Gremlin, TitanDB. There are so many NoSQL databases. You would be surprised to know that NoSQL being a new world, still there are more NoSQL databases than the SQL databases. That's because every organization who had some challenges, they implemented, created their own database, and then kind of made it open source and so that others can use it and all of that. So do we have any NoSQL offering in the AWS world? What if I want to work with NoSQL data? Do we have any offering? We have an offering of DynamoDB. DynamoDB is a NoSQL database of AWS. Just like in Azure, we have Cosmos DB. AWS has got DynamoDB over here. Now, if you're new to this space, hold on. I'm going to cover DynamoDB also, and I'm going to show you how does DynamoDB work over here. That's what the DynamoDB over here is. Then obviously, we want to work with relational data warehouses. We have already spoken about it, but let me kind of mention it over here. What about implementing data warehouses, relational data warehouses, analytical databases? What's the storage that would be used in this particular scenario? Typically analytical databases. We know the answer, folks. I've already spoken about that. What's that? You've already spoken about this multiple times. What's that AWS service to implement relational data warehouses? Come on. Test of your memory. Lots of services, I know. Come on, folks. AWS Redshift, isn't it? So if you are here to implement the data warehouses, we have a service called as a Redshift. We did speak about that in the BI lifecycle. We did speak about it when I was talking about the data warehouses. If you want to implement the relational data warehouses, you have to then think about a storage within the Redshift over here. So that's my sixth offering that we are going to see it over here. So when you think about storage in AWS, you have EBS volumes and EFS. I'm not going to use EBS volumes and EFS. That's typically your block storages used for machines and all of that. We would always need independent data storage. So I'm going to use S3 for most of my data storages, file storages, independent storages, object storages. When I need a relational data offering, I'm going to switch back to RDS. When I need a NoSQL data to be stored, I'm going to use DynamoDB. When I need to have data warehouses to be built, I'm going to switch to my AWS Redshift. Those are a different kind of offerings that we have here. Look at that, folks. How do we go about working on all of that? I'm going to say storage services part 2. Folks, lots of things covered, and I'm sure you are at least getting a grip of, if not the details, you're at least getting a grip of what are we trying to see inside this particular thing. Now, before we go ahead, as I said, I'm going to gauge the learning at multiple stages. So I'm going to host one small quiz, a very simple quiz. I'm not even going into the AWS, but just to see how much do you understand from this session. So here we go. I've launched a small quiz. All you need to do is to connect to the quiz. Just go to kahoot.it. Join from your mobile phone. It will be difficult for you to manage two screens. So you can go back to your mobile phone, put in kahoot.it. And then you'll be asked for a game pin. Put this game pin. Alternatively, you can directly scan this QR code and then give your name. Don't give your short names, at least give your first name so that we can identify. I'll wait for say 45 seconds. This is the first quiz you are getting acquainted. So I'll wait for say 45 seconds to a minute. Please join the quiz. Brahma has joined, Shruti has joined. Thank you. Mehta has joined. Wonderful. Okay, I will move on. Simple foundations. Let's see how much do you can remember and grasp from the data engineering foundations. Simple. Which of the following is not one of the V's of big data? Obviously, there's nothing called as a vacuum. The volume, variety, and velocity is what are the three V's of big data. Vacuum has got nothing to do with big data. Mehta, Balaji, Brahma leading the battle. Let's go to the next one, please. It's a multi-select. So you can select multiple options, which could be correct. Which of the following are examples of unstructured data? Okay, so what is unstructured data is not database tables. Database tables is a structured data. XML file can be classified as a semi-structured data. It has got at least some structure, but videos and images, they are classified as the unstructured data. XML file could be classified as a semi-structured data. Mehta, Brahma, Balaji leading the battle. Let's go to the next one. Absolutely. So big data can work with unstructured, structured, and semi-structured data. What we of big data that we are looking at? Obviously, we are looking at variety. We are not looking at volume. Volume means a lot of data. But I'm saying it can work with unstructured, structured, and semi-structured data, which means what element of V that we are looking at is a variety of data. What's that data variety? It can work with structured, unstructured, and semi-structured data. Mehta, Brahma, Balaji leading the battle. Let's go to the next one. Real-time data processing needs what? This is an interesting one. Real-time means the data that comes from IoT devices, like I was giving an example, it comes from that constantly flowing data. What can it be called as? Absolutely, it's called as a stream processing. Now, if you didn't kind of use that word stream, what is that constant data flowing called as? It's a stream. The word stream comes from the word water. We have a water stream, the water which constantly flows. So when data flows constantly, kind of continuously, we call it as a stream. And that processing of the stream, the real-time data, is called as a stream process. That's the kind of objective over here. Mehta, Brahma, Balaji leading the battle. Now, this is an interesting one. It's talking about the data engineering roles. The one who gathers the data, reviews the data, analyzes the data, what kind of a data engineering role or what kind of a data role he is into. A logical question. Just want that you are able to understand that different data roles. Look at it, gathers the data, reviews, analyzes the data to get the data insights. Now, it's not a data engineer. The data engineer is not to analyze the data or review the data or do anything about that. It's a data analyst as a role who is basically thinking about analyzing the data and getting the insights. The objective of that data engineer role is to build those data pipelines, to think about the data movements. I'm not even talking about data pipelines and data movements and creating those, data pipelines and workflows. No, I'm saying the one who gathers, analyzes, and reviews the data. I would rather make it as a data analyst. I think some of you got it right. I'm glad. Mehta, Brahma, Balaji leading the battle. Let's go to the next one. Now look at that. He creates the infrastructure for enterprise systems, ensures data quality, security, and monitoring. So which means now I'm talking about building that pipelines. What's that role called as? Absolutely, got it right. I think I gave you the answer here. So look at this. A data engineer is the one who thinks about creating those data pipelines. But is he just responsible for creating data pipelines? No. He's the one who thinks about quality of data all the time. Garbage in, garbage out. If data quality is not good, the data analysis in future won't be good. Security of the data. Constantly having a governance and monitoring strategy for, monitoring and governing the data in place. We are going to talk about that data profiling, data quality in the later stages of our sessions. Data engineer covers all of those particular aspects. So important. Mehta, Brahma, Balaji leading the battle. Last two to go. It's a multi-select, seventh one. What clouds we can use for storing the data? Choose what applies. Interesting to see your cloud skills from previous session. Absolutely. I'm glad that most of you got that right. So you can use public cloud for storing the data, which means AWS or Azure or GCP. But there could be some data that you might want to keep it private. Or there could be data which you want to keep it private. That is private cloud. On your premises, in your data centers, you don't want to make it public. But what is hybrid cloud? where you can have some data on the public cloud, AWS or Azure or GCP. For example, that insensitive data, you can keep it on the public cloud, and some data you can keep it private in your premises, in your organization, in your data centers. And when you do that, that's called as a hybrid cloud. So working with data completely on the cloud, public cloud, completely on the in your premises, private cloud. You make a partial data on public cloud and partial on the private cloud. It's called as a hybrid cloud that you are going to have. Wonderful. Mehta, Brahma, Balaji leading the battle. Last one for today. Relational database tables is an example of what? I think this should be super simple for you. Is it structured data or unstructured data or semi-structured data? Obviously, it's a structured data. No discussion required on this. So on the leaderboard, at number 3, we have got Balaji. Congrats. Number 2, we have got Brahma. And somebody to be spotlighted for today is Mehta. And there are 2 runner-ups, Coleridge and Shruti, who are the runner-ups for today. Congratulations, all the winners. Folks, just one last thing before we kind of wind up. So while we'll take frequent feedbacks, there would be intermediate feedbacks that the team would be sending and all of that. You would see some feedbacks coming from our teams. But I believe in early feedbacks. The last day feedbacks and the later feedbacks are probably for formalities. So the earlier feedbacks is something that I would be interested in. Can I request you that you spend not more than 2 to 3 minutes? It's not going to take more than 2 to 3 minutes. And hence, can I request each one of you to go into the link which I put in the chat box?
So I hope you enjoyed this video. Just a quick reminder, make sure to grab the opportunity to register for our free live masterclass that I mentioned earlier. Click the link in the description below to register. Also, don't forget to subscribe for more such valuable content. And also make sure you watch this video next.